This video will discuss rational exponents, and we will utilize rules that have been discussed using integer exponents, positive, negative, whole number exponents. But with this video, all of our exponents will be, in some form of fashion, will be fractions. So we're going to use the same rules that we would use when we were doing exponent rules with integers, except now we're going to do the same rules, except that they'll be fractions. So the objective is to look at the product rule, the quotient rule, and what happens when we have negative exponents or a zero as an exponent, and then the power to power rule. The product rule states that, as indicated here, that if the bases are the same and you're multiplying with bases and exponents, if the bases are the same, you're allowed to add those exponents together. Now, in the course previous to this, the exponents that were mentioned and discussed in class were integers. So m and n, in this case, would be fractions. So let's look at part A. And since we have coefficients, we would be allowed to multiply those. So 3 times 3 is 9, 9 times 4, I get 36x. Now I have 1/2 plus negative 3/4 plus 2/3. So since I have the same base, I can add these exponents. Now these coefficients I'm allowed to multiply, which give me 36. So remember, when we're looking at fractions and we want to especially add them, then we're thinking of an LCM. So 36x to the, and we're looking at halves, fourths, and thirds. So we would say twelfths would be an LCM. So 1/2 would be 6/12, negative 3/4 would be negative 9/12, and 2/3 would be 8/12. So to simplify that, we would have 6 and the negative 9 would be negative 3. Negative 3 plus 8 would be 5. So this would be our rational exponent form. And the radical form would be 36 times x is the base, 12 is the root, 5 is the power. So that's called your root or index, and that would be your power. So let's look at part B. Here was part A. So part B would be 3x to the 1/2 power times x to the 4/3 power. Now, since 2 and 3 are my denominators, so I'm thinking an LCM of 6. And this has a constant of 1, so that coefficient would be 3. 3 times 1, and then since I'm multiplying using the product rule, I need to add these together. So 1/2 is the same as 3/6 plus 4/3 would be the same as 8/6. So to simplify, 3/6 plus 8/6 would give me 11/6, and that would be in rational form, rational exponent form. And if I want the radical form, x is the radicand with a power of 11 and a root of 6. And we'll talk more about radical and rational forms in the future. Again, we're using the product rule. So part A, you get to multiply 5. 4 and negative 2, so that's 20. That'll be negative 40. And since a base of x, they're all the same, so it will be negative 2/7 plus 1/2 plus 4/7. So negative 40x halves and sevenths, so we'll say 14ths. So LCM is 14. Negative 2/14 would be negative 4/14. Excuse me, negative 2/7 would be negative 4/14. 1/2 would be 7/14. And 4/7 would be 8/14. So negative 40x, and then this would be negative 4 and 7, so that's positive 3, and 3 plus 8, so I get 11/4. So negative 40 times x raised to the 11/14 power. That's your rational form. Radical form would be negative 40 times the radical of x to the root of 14 to the 11th power. Part B, we get to multiply 3, 2, and 2, so that's going to give me 12. And I'm going to have halves, fifths, and fifths, so I'm looking at the denominators, and that's going to be tenths. So negative 3/2 would be the same as negative 15/10, plus 2/5 would be the same as 4/10, plus 6/5 would be the same as 12/10. Since the denominators are the same. And that is a base of x. So I need to make sure I have my x. So 12x to the, this is negative 15 plus 4 is negative 11. Negative 11 plus 12 would be 1/10. So halves, fifths, and fifths. Here's our rational form. And the radical form of 12 times x to the 10th root first power. Again, with the product rule, I see I'm multiplying. I have bases of x. So 4 times 2 times 2, that's going to give me 16. And x is a base, and so fifths, fifths, and fifths. So since the denominators are the same, and I'm just going to add the numerators. 2 plus 4 is 6. 6 plus 9 is 15 fifths. And 16x 15 fifths is 3. And so there is my, it is a rational exponent form because it still can be written as 3/1. However, that is not the format we have to write it in. We're going to leave it as a, in this case, it happens to be an exponent that's an integer. So that's all with product rule. And then we're going to look at the quotient rule. And the quotient rule states that if we're dividing exponents and the bases are the same, then you're allowed to subtract the exponents. So with the case of this one, notice here, these are coefficients. So we're still going to divide those numbers. Negative 2/10 would be the same as negative 1/5. You always want to try to simplify as much as you can. Now here, what we'll do is we'll leave everything in the numerator. We'll say x to the 7/3. When I mean leave everything, we're just going to leave our work of our subtraction in the numerator. 7/3 take away 5/4. Now that will become thirds and fourths, so the LCM would be 12ths. So we've got negative 1x and that will be to the 28 twelfths and the 15 twelfths, all divided by 5. So negative x, 28 minus 15 is 13 twelfths, all divided by 5. That's the rational expression. And the radical would be negative 1/5 times x to the 13th power, and the denominator was 12, so it's the 12th root. So there's your radical. Okay, part B. 9 divided by 3 is 3, and the quotient will stay in the numerator. And so now that's going to give me y to the negative 1/3 subtract negative 7/4. And all that's divided by 1. And so I get 3y to the negative 1/3 plus 7/4, which makes the LCM 12. So that's going to give me 3y to the negative 4/12 plus 21/12. So that'll be 3y to the negative 4 plus 21, or 17/12. So there's your rational form. And your radical form would be, the base is y. So y to the 17th, we'll take the 12th root. So here's your radical form. Again, with the quotient rule, I know it's quotient rule because I see the division signs. So 4 divided by 2 is 2. The quotient is in the numerator in this case. X to the second, take away 1/2. Well, I can say that 2 is the same as how many halves. So we would say 2x to the 4 halves minus 1/2. And all that would be is 2x to the 3 halves. So there's your rational form. Your radical form would be 2 times the second root of x to the 3rd power. All right, part B. I need to kind of simplify the denominator first before I start to divide. So again, in the denominator is actually using the product rule. So 3 times 2 is 6. And x to the 1/8 and x to the 2/8, the denominators are actually the same, so that would be x to the 3/8. I'm allowed to add those. Why? Because the bases are the same. I'm allowed to add 1/8 and 2/8. So now I get 3/6, which is equivalent to 1/2, and I'm dividing, so now I'm going to have 3/4 take away 3/8. Common denominator of 8, LCM of 8. So that's going to give me 6/8 minus 3/8, all divided by 2, which would be x to the 3/8 divided by 2. Or, to simplify the numerator, would be base of x to the 3rd power, the 8th root, divided by 2. So there's your radical. There's your rational. Quotient rule again, because I see division, and I see bases of x, and I see bases of y, and I see 4/6. So 4/6 simplifies to 2/3. This is x to the 3/4, take away 1/2, all multiplied by y to the 2/3, take away 1/4. So notice I put everything in the numerator. I'm just showing my subtraction. So 3/4 and 1/2, so that would be 3/4 take away 2/4 for x. For y, it would be twelfths. Thirds and fourths would say twelfths. So that would be 8 twelfths minus 3 twelfths. All that's divided by 1. So this will be 2x to the 1/4 times y to the 5 twelfths. There's your rational form. Radical form would be x to the 4th root, 2 times the 4th root of x times the 12th root of y to the 5th. And we'll look more at radicals later in our unit. So far we've taken care of the product rule, we've taken care of the quotient rule, and so now we're going to look at negative exponents. And what this means, this definition is saying that if any time we have a base to a negative exponent, we are allowed to write it as a reciprocal. And we'll look at the next page where it looks at some patterns, and we'll look at those in class as well. And then notice here it's saying that what if you've got a fraction already raised to a negative exponent power? Well, you can take the reciprocal and make it positive. So that's what we're looking at. We're looking in regard to reciprocals. So if it's negative in the numerator, we can move it to the denominator by taking the reciprocal, and it would be positive, and vice versa. So here, I'm actually going to combine some rules with negative exponents. This is actually using a power-to-power rule, which we'll talk more about next, but I want to look at just the result of what happens. So I get x to the negative 2/7 times y to the 2/21. Now, how did I get that? Well, it's 2 times negative 1/7, and negative 2/3 times negative 1/7. That gives me the 2/21, divided by x to the 1/14 times y to the 3/7. So I had to incorporate the power to power rule, and now it looks like I'm going to have to use the quotient rule, and then we want to look at what's the result of using the quotient rule. Well, both have bases of x, so it'll be x to the negative 2/7 minus 1/14, and y to the 2/21 take away 3/7. So nothing in the denominator but 1. And if I keep going, I need a common denominator. We'll say 14th, so negative 4/14 minus 1/14. That's all to the x power. And y would be 21st, so it would be 2/21 minus 9/21. 9/21, same as 3/7. So we look at simplifying. So I get x to the negative 5/14 times y to the negative 7/21. So what we're seeing here that's different than our first time with the quotient rule is look at the exponents. They're negative now. So how would that simplify? It would simplify as x to, it's not negative 5/14 now, it would be positive 5/14, and y is not negative 7/21, it's going to be a positive 7/21. Now 7/21 will simplify, so I get x to the 5/14 times y to the 1/3. So there's your simplified form for this problem. Again, I'm going to use the power to a power rule again. So I get x to the 10/2 times y to the negative 6/4. And then I want to simplify what I can. So x to the 5th times y to the negative 3/2 power. Well, you're only looking at the exponents. That's what your negative exponent rule speaks to. And so since it is negative, we're going to leave x to the fifth in the numerator because it's positive, and we're going to move y to the denominator. It's not going to be negative 3/2 anymore. It'll be positive 3/2. So there's your rational form. Again, we're going to go power to a power rule. So this is actually 3 to the second times x to the negative 4 times 2, so negative 8. 6 to the second times x times negative 3 times 2 would be x to the negative 6. So notice here, that's 3 to the second, that's going to be 9. 6 to the second, that's 36. X to the negative 8 minus negative 6. Negative 8 minus negative 6. There's the quotient rule. Now I can simplify 9/36 to be 1/4 x to the negative 2 power. And so that will simplify to be 1/4 with x to the second in the denominator. It was in the numerator negative exponent. It's moved to the denominator using the reciprocals, and it's now positive. So that moves us on to what happens when we get 0 as an exponent. And we know we'll look at some patterns from class tonight, but anything to the 0 power will be 1. So again, I'm utilizing the power to power rule. So negative 4 to the second power, everything is raised to the second power, so that's x to the negative 4/3 divided by 64, x to the negative 4/3. Well, negative 4 squared, that's going to be 16. So I get 16 x to the negative 4/3 divided by 64 x to the negative 4/3. Well, 16 64ths will simplify to 1/4. And because 16 will divide 64 4 times. Now what we have here is x to the negative 4/3 take away, since it's quotient rule, take away negative 4/3. So what happens when you have negative 4/3 take away negative 4/3? It actually becomes addition, and you're left with 1x to the 0 power divided by 4, and anything to the 0 power is 1. So your answer is actually just 1/4. Here I've got the product rule, since there's only an exponent of 1, so we're not really looking at the power to power rule. This is going to be a product rule. So 2 times negative 3 is a negative 6, and this is x to the 2/3 plus negative 2/3. Remember, product rule allows you to add the exponents when you're multiplying. So what is 2/3 plus a negative 2/3? Goes to 0. So negative 6 times 1, and you get negative 6. Now here's that power to power rule. Anytime you're raising an exponent to a power, as we noticed in some of the work there previous, you get to multiply those. So here I've got on part A, or number 1, I've got 64, and it's actually to the first power. So you're raising it to the 3/2 power. So 1 times 3/2 is 3/2. X to the 4th power times 3/2. So what you get is 64 to the 3/2 power times x to the 12/6 power, and 12/6 is 2. So 64 to the 3/2 power is actually, in radical form, would be what's the square root of 64, but take the result to the 3rd power and multiply it by x squared. So the square root of 64 is 8, and then 8 to the 3rd power is a large number, and that should be 512. So taking the second root of 64, which another way in your calculator, you can type 64 to the 1/2 power, and that'll give you 8. And then you're going to take 8 to the 3rd, which should be 512 x to the 2nd. All right, part 2, everything's raised to the 2nd power, so it's going to be x to the -2. So -1 times 2, then it'll be 1/3 times 2, -4/3 times 2, and 2 times 2. So that should be y to the 2/3 times x to the -8/3 times y to the 4th. So start putting together your like terms, and that's what you'll add together in this case. X to the -2 plus -8/3. Well, the LCM would be thirds. So it'd be x to the -6/3 plus -8/3, and that would give you x is -14/3. Now what about y? Well, I've got x to the -14/3, and y is going to be 2/3 plus 4. So I got x to the -14/3 times y to the 12/3 is the same as 4, so that would be 2/3 plus 12/3 would be y to the 14/3. So when you look at this, you see that one of them has that negative exponent, and it's right there. So that one will use the reciprocal and move to the denominator. So you'll have x to the 14/3, and y stays in the numerator to the positive 14/3. Again, power to power rule. So the 9 and the 27, they both need to be taken to the 1/2 power. So number 3, it's 9 to the 1/2 times x to the 4/2. 4 times 1/2 would be 4/2. So the square root, this is really what it's saying, is the second root of 9, which is 3, and x to the 2nd power is the final result for number 3. And then number 4 is take 27 to the 1/3 power times x to the 3/2 power times 1/3. Well, what times what gives you 27? That's what it's asking. So what's the cube root of 27? And it would be 3. So 27 to the 1/3 power. So 3 times 3 is 9 times 3 is 27. So that's x. Now, what's 3/2 take away 1/3? Well, the LCM would be 6. So that's 9/6 and 2/6, which would be 3x to the 7/6 power. And that's your rational form. If you wanted radical, the x is with the radical, and it would be to the 6th power and the 7th root. Notice the denominator is the root, and it went into the index place on the radical sign, and 7 is the exponent. Okay, final one. We're going to take every term to the -5/4 power. So x to the -1/2 times -5/4 is 5/8 times y to the -10/4 divided by x to the -10/4 times y to the -5/8. So once I use power rule, now I need to use quotient rule. So I did the power rule, and now I'm using the quotient rule. So x to the 5/8 take away 10/4, and y to the -10/4 take away negative 5/8. That makes that positive. So LCM of 8, so x to the 5/8 minus 20/8 times y to the negative 28 plus 5/8. So since we were multiplying, since we were dividing, we were allowed to subtract the exponents. And I just got to be careful. I think I had an integer error. So let me go back. 5/8 take away a negative 10/4 is going to be a positive. And negative 10/4 take away negative 5/8, that looks correct. So this will be x to the 10/8 plus 20/8 times y to the negative 28 plus 5/8. So 10/8 and 28, so that would be x to the 30/8. And y to the negative 15/8. Well, one of those can move to the denominator because it's negative, and that would be this one. And 30/8 can simplify to, let's see, both divisible by, so 2, so that'd be 15/2, and y divided by 15/8 would be in the denominator. So just to recap, product rule. When we had the product rule, it involved adding the exponents. Quotient rule involved subtracting the exponents. Negative exponent rule asked us to think about using reciprocals. And 0 as an exponent, we saw that became 1. And then raising a power to a power is using multiplication. So we get to multiply the exponents.